Children, today we will study the chapter 13 factorization. So first we will know about the factors. 5 and x are the factors of 5x. Similarly, 2x minus 5 and 3x plus 2 are the factors of the product 2x minus 5, 3x plus 2. Now we will know how to factorize of the given polynomials. So first method is by taking out common factors. So here we have the polynomial 5x square minus 10x and we will factorize it. So how can we will find by the inspection that 5x is the monomial, the greatest monomial that can divide the both terms of the polynomials completely. So taking out 5x outside, so inside the bracket we have 5x square upon 5x minus 10x upon 5x, that will give 5x in the bracket x minus 2. So in that manner you can factorize 5x square minus 10x. So similarly you can do the sum of the exercise 13a. Children, I am taking question number 1 of exercise 13a, in which we have factorized 15x plus 5. So by the inspection we can find easily that 5 is the greatest monomial that can divide the both terms. So taking out 5 outside, so we have the 5 inside the bracket 3x plus 1. So in that manner you can factorize 15x plus 5. Now I am taking question number 2 in which we have a cube minus a square plus a cube minus a square plus a. By the inspection we can find easily that a is the greatest divisor or the greatest monomial that can divide each terms. So taking out a outside, a cube upon a, that will give the a square upon a, that will give the a upon a, that will give the 1. So a in the bracket a square minus a plus 1 is the answer of question number 2. Now I am taking question number 5. 2x cube b square minus 4x to the power 5 b to the power 4. By the inspection we can find easily 2x cube b square is the greatest monomial that can divide both terms both completely. So taking out outside, inside the bracket we have 1 minus 2x square b square. So in that manner you will do question number 1, 2 and 5. Children, I am taking question number 8 of exercise 13a, in which given 6x square y plus 9x y square plus 4y cube. So by the inspection we can find easily y is the maximum divisor or the greatest monomial that can divide each terms completely. So taking out y outside, we have inside the bracket 6x square plus 9xy plus 4y square. So that is the answer of question number 8. Now I am taking question number 11. X square in the bracket a minus b minus y square in the bracket a minus b plus z square in the bracket a minus b. Whenever we inspect that, we will find that a minus b is the maximum divisor or the greatest binomial that can divide the each term completely. So taking out a minus b outside, so we will have the inside the bracket x square minus y square plus z square. Now I am taking question number 13. 2b 2a plus b minus 3c 2a plus b. By the inspection we can find easily 2a plus b is the greatest binomial that can divide both terms completely. So taking out 2a plus b outside, inside the bracket we will have the 2b minus 3c. So in that manner you will solve the question number 8, 11 and 13. Children, I am taking question number 15, that is 4x in the bracket 3x minus 2y minus 2y in the bracket 3x minus 2y. So by the inspection we can find easily that 3x minus 2y is the greatest divisor that can divide both terms. So taking out the 3x minus 2y outside, we will have the inside other bracket that is 4x minus 2y. So in that manner you can factorize question number 15. Now I am taking question number 17, that is 6xy in the bracket a square plus b square plus 8yz in the bracket a square plus b square minus 10xz in the bracket a square plus b square. So by the inspection we can find easily that a square plus b square dividing each terms completely. So taking out outside, so in the other bracket we will have the 6xy plus 8yz minus 10xz. So in that manner you will factorize question number 15 and 17. Children, I am taking question number 1 of exercise 13b, in which we have to factorize a square plus ax plus ab plus bx. So this polynomial we will solve or factorize by the grouping method. So by the grouping method, how will you solve it? So make the group or the pair. So a square plus ax and the other pair is AB plus BX. So whenever we see or we inspect that first pair, we will find that A is the maximum divisor that can divide both term A square plus AX. So take it outside, we will have the A square upon A, that will give the AX upon A, that will be the X. So first pair we have solved out in that manner, and the second pair we will have AB plus BX. Whenever we inspect that, we will find B is the greatest divisor that can divide both terms AB and BX. So taking out outside, so B in the bracket we will have A plus X. So now we have another two terms in the next step. So A plus X plus B, A plus X. So whenever we inspect that, A plus X is the greatest divisor or having common in both terms, so we will taking out outside. So A plus X taking out outside, so inside the other bracket we will have A plus B. So in that manner you will do question number 1. Now I'm taking question number 4, A cube minus A square plus A minus 1. Making pair A cube minus A square plus A minus 1. We will see the first pair. A square is the maximum divisor or the greatest divisor that can divide both terms. So that will taking out outside. So we will have in the bracket A minus 1. In the second bracket we have nothing common, nothing is the divisor. So we will take 1 as a divisor. So we will write 1 and in the bracket A minus 1. Now in the second step we will see that A minus 1 is dividing the both terms. So we will taking out outside A minus 1, in the bracket we will have A square plus 1. So in that manner you will solve the question number 1 and the question number 4. Children, I am taking question number 6, exercise 13b, and the question is that xy minus ay minus ax plus a square plus bx minus ab. So first make the pair. So 3 pair we have here. In the first pair we can take y common. So take y common, inside the bracket we get x minus a. In the second pair we are having the a common. So we can take the a common from these two terms. So whenever we take the a common, we will get the x minus a inside the bracket. In the third pair we are having the b common. So take the b common, in the bracket we are getting x minus a. In the second step, whenever we see x minus a in all the terms, so x minus a taken outside. So in the bracket, in the second bracket we are getting y minus a plus b. So in that manner you can factorize the question number 6. Now I'm taking question number 8. The question is minus x square y minus x plus 3xy plus 3. So make the pair. 2 pair we are having. In the first pair we are having minus x is common. So take the minus x is common. Inside the bracket we are getting xy plus 1. And in the second pair we are having the 3 common. So take the 3 common. We are getting xy plus 1. Now from the second step, whenever we see xy plus 1 in both terms. So take the xy plus 1 from the both term common outside. Inside the bracket we are getting minus x plus 3. Change this minus x plus 3 into the 3 minus x. So we are getting answer is xy plus 1 and 3 minus x. So in that manner you will solve the question number 6 and 8. Children, I am taking question number 11 of exercise 13b, and question is that x square minus a minus 3 in the bracket x in the product minus 3a. So first we will multiply x to the a minus 3 inside the bracket. So we are having x square minus ax plus 3x minus 3a. Now make the pair. The 2 pair we are having, and in the first pair we can take the common x. So whenever we take the common x, inside the bracket we are getting x minus a. Similarly, from the second pair we can take the 3 common. So 3 and the inside bracket we are having x minus a. Now x minus a we are having common in the both terms. So taking out x minus a, and in the bracket we get x plus 3. So in that manner you can do question number 11. Now I am taking question number 13. Question number 13 is that a b minus c in the bracket minus d c minus b in the bracket. So whenever we see the first term, we are having the b minus c. In the second term we are having the c minus b. First change this sign. So how can we take the minus 1 common? So whenever we take minus 1 common, we are getting plus d, as because the minus and minus will give the plus d, and inside the bracket we are having b minus c. So now we are having the two terms a b minus c plus d b minus c. So whenever we see the two terms, b minus c is the common in both. So b minus c taken the common, and inside the bracket second bracket we are getting a plus d. So in that manner you can do question number 11 and 13. Children, I am taking question number 16, and is that a cube minus a square minus ab plus a plus b minus 1. So first we will change from the position of the a, we are changing this one. So we are writing b first and the a later on. So now make the pair a cube minus a square as the first pair, ab plus b as the second pair, a minus 1 as the third pair. So in the first pair we are having the common a square, so in the bracket we are getting a minus 1. In the second pair we are having the minus b common, so in the bracket we are getting a minus 1. In the third pair we are getting 1 common, so plus 1, and then in the bracket a minus 1. So in the third step, whenever we see a minus 1 is common in all these three terms, so take the a minus 1 common, and inside the bracket we are having a square minus b plus 1. So in that manner you can do question number 16. Now I am taking question number 18, and question number 18 that 2ab square minus aby plus 2cby minus cy square. So make the pair, two pair we are having here. So from the first pair we are taking ab as a common. So in the bracket we are getting 2b minus y plus cy we are taking common in the second pair. So in the bracket we are getting 2b minus y. Now from the second step we are having 2b minus y is a common in a both term. So take the 2b minus y common, and in the second bracket we are getting ab plus cy. So in that manner you can do question number 16 and 18.